Hi, this is Alex from devstories.eu. PyTorch Fundamentals, episode 12 of 18. To teach a neural network to be right, you first have to rigorously measure exactly how wrong it is. If you cannot quantify failure, your model cannot learn from it. That brings us to understanding loss functions. When an untrained network processes data, its output is essentially a guess. A loss function evaluates that guess. It measures the degree of dissimilarity between the result the model produced and the absolute truth of the target value. The output of a loss function is always a single scalar number. Your entire training process exists to push that single number as close to zero as possible. Because different machine learning tasks have different definitions of being wrong, PyTorch provides several loss functions. If you're building a regression model to predict a continuous value, like the temperature tomorrow, you measure the distance between your guess and the real temperature. For this, you use mean square error, which in PyTorch is called nn.MSELoss. But classification is different. Suppose you have a model categorizing images of clothing into 10 fashion categories. The model looks at an image of a coat and outputs 10 raw scores, one for each possible category. These raw, unnormalized scores are called logits. The true answer is just a single integer representing the correct class. You cannot just subtract a class index from a raw score. Instead, you need a function that penalizes the model for giving low scores to the correct class and high scores to the wrong classes. For classification, the standard tool is nn.CrossEntropyLoss. You initialize your loss function, pass it the 10 raw logits from your model alongside the correct integer label, and it returns your scalar penalty. This is the part that matters. There's a massive trap here for developers. In many machine learning textbooks, a classification network ends with a softmax layer. Softmax forces raw logits into a neat probability distribution where all the scores add up to exactly 1. Because of this, developers often manually add a softmax operation at the very end of their PyTorch model. If you are using nn.CrossEntropyLoss, doing that is a mistake. In PyTorch, nn.CrossEntropyLoss automatically applies a log softmax function internally before calculating the negative log likelihood. It's built to accept raw, unnormalized logits directly. If your model outputs probabilities because you already applied softmax, passing them into nn.CrossEntropyLoss means you're applying the math twice. This compresses your gradients, drastically slows down training, and ruins your model's ability to learn effectively. The rule to remember is that your neural network should just output raw numbers. Keep your model outputs raw, hand them straight to nn.CrossEntropyLoss, and let PyTorch do the heavy lifting of turning those logits into a meaningful penalty. Thanks for listening. Happy coding, everyone.